hope that construction won't continue through the.
I don't remember this yesterday. Better the meeting room than the hotel room at night. Good morning.
Kind of a large room and a large block of time for this session.
Yes, and we will need neither, hopefully.
We were rescheduled from a smaller block of time, I believe, to.
Maybe we'll need to pause every time there's construction.
Indeed.
We could have probably squeezed into it in a 1 hour block, but just to give comfort and and avoid any cutting people off at the longer slot. Just give it 1 more minute. Start 5 past.
That's what I was thinking. Okay, let's get started. This is machine learning for audio coding. If you're expecting to be somewhere else. Yeah, okay. This is machine learning for audio coding. If you're expecting to be in a different session, you're in the wrong place. Note well, this is an official proceeding of the IETF. So your activity here is subject to a number of IETF policies, which are noted on this slide. You should be aware of these policies before participating in any IETF activity. The Those policies also include standards for conduct, including anti-harassment, and so you should be aware of those as well. We all want to treat everyone with respect and decorum. This is the last day of the meeting, so hopefully people are already familiar with the tools. But in particular, if you're in the room, you need to log in to the online tool in order to register your participation in the room, and also to get in queue for the mics if you seek to do so. Yeah.
It's going to be fun.
Apologize for the construction. We aren't compressed today for time, and so if people are, need anything to be repeated because of background construction noises, please just ask for it to be repeated.
Thank you, Stefan, but unfortunately, I think it's right above us. Thank you. Can you close the upper doors?
Can we get anyone to volunteer to take notes for today? There shouldn't be a significant amount of note-taking required.
Just capture the major items, and the notepad is already pre-populated with the agenda, so it should just be a few sentences.
Thank you.
Thanks, Jonathan.
Okay, so do we have any agenda bashing? The agenda as we have set out today simply has the updates on a number of the drafts that people have been working on around the working group, the opus extension mechanisms, the deep redundancy, and the speech coding enhancements. We have time available, so there should be plenty of room for questions if any come up. Okay, well, no agenda bashing, but we can hand it over to Tim.
All right, if you guys can still hear me.
Yes, you're loud and clear.
And I'm going to hand you control of your slides.
Oh, great. Now I got to figure out how to use that.
Yeah, you should have control. So there you go.
Yeah, okay. I got arrows. I can do it.
All right.
All right. So this is the extension draft. There's been no changes to the actual draft for 2 meetings now. So we submitted a 0.2 version just to refresh the expiry date. So you may recall these diagrams from a previous presentation, basically showing the actual format of an Opus frame and how the extensions fit into that. And so the thing that I want to highlight on here for this presentation is the amount of overhead it takes in order to actually send some extension information. So if you're just sending a single frame, you have to use a code 3 packet, which has this extra frame byte count in it, in order to get the padding bit to turn padding on. So that's 1 byte of overhead. You need to signal the padding length, which can be multiple bytes, but it's at least 1 byte. And then in the actual padding itself, you need to signal an extension ID. And only after you've done all of that, you can start actually signaling extension data. So at a minimum, you have 3 bytes of overhead. If we look at the multiple frame case, you already have the frame count byte, so that doesn't count as overhead. But now for every frame, you have to include both, the extension ID as well as one of these separators to mark the boundaries between frames. And the first frame has, again, the padding length. So you have 2 bytes of overhead for every frame. So to sort of look at a motivating example, this was the reason this issue was originally raised. One thing that people will do is they will set P time to 60 milliseconds to try to reduce header overheads, right, from RTP and ITP and UDP and all that. And so when you do that, what often happens is you can free up enough available bandwidth to actually use hybrid mode or even CELT, which leaves you with encoding 3 by 20 millisecond frames in a single packet. So now if you want to add extensions to those frames, if we take like the minimum amount of extension information that we can send that has an actual payload per frame, so we say 1 byte extension on each frame, you wind up having 2 bytes of overhead for each 1 byte of payload. So for the 3 frames, it takes you 9 bytes in order to send 3 bytes of data. You know, when you're in the compression business, that's not great, right? So it occurred to me that a lot of these bytes are in fact pretty low entropy and easily predictable, so that we ought to be able to do better than that. And so the proposal I came up with was this. It is a new repeat these extensions extension. So we don't, you know, we may not necessarily know exactly how extensions are going to be used, but it seems like a pretty common use case that you're going to want to use the same extension over and over again in every frame. So this adds a new mandatory to implement extension with ID equals 2. When you encounter it in the current frame, for each frame after the current frame in the same packet, and for each extension that you've already seen in the current frame, you decode an extension of the same type for the next, you know, those following frames. And this happens right away. So as soon as you see that ID equals 2 extension, you go through and decode all these extra extensions for future frames. If they're short extensions, they use the same L flag as the original because the L flag is in the extension ID byte. So we're omitting the ID bytes for these repeated extensions and just coding the payloads. If it's a long extension, then you explicitly code a length for each long extension, unless the L bit was 0 for the RTE extension and you're on the last extension. So for the very last extension of the packet, if it's a long extension, you don't need to code the length. Sort of the same as normal. On the other hand, if the RTE extension had the L flag set to 1, then after you've done recoding all these repeated extensions, you go back to coding extensions for the original frame C. And finally, if it had L equals 0 and it didn't end with a long extension, so you didn't wind up consuming the rest of the packet and there's still some more data, then continue decoding extensions for the next frame. So it basically allows you to sort of save a separator byte to advance to the next frame in that case. If you already were on the last frame, then you know you do the encoder must fill with zeros, decoder must ignore the rest of the packet. Not that there's really a reason to repeat these extensions in the last frame because there's no frames to repeat things in. So before I move off this slide, did I confuse everybody or does any of that make sense?
Jonathan looks maybe perhaps confused.
All right. Well, I'll maybe go through the example or yeah, if you want to say something, Mike, too, we can ask.
Sorry, I forgot to use the queue. Yeah, I think the general idea looks good. I didn't quite follow the algorithm, but since you're the one who has to implement it, I don't care that much.
Fair enough. So basically, to go back to our 60 millisecond packet with 320 millisecond frames example, if we want to send a 1 byte extension on each frame, We have to spend 1 byte to code the padding length. That didn't change. 1 byte for the extension ID in the first frame, and then 1 byte to signal the repeat these extensions extension. And then you just immediately code the payload for the other extensions without having to signal any extension IDs or any frame separators. So in total, you have 6 bytes.
So Tim, can you go back one slide, please?
Sure.
So maybe to help some of Jonathan's confusion, because I think maybe I had some of the same confusion on his, even when I read it before, still not sure even after your description. Is the position of this repeat this extension significant? Are you trying to signal that the extensions that came before this were only one shot and the ones that came after this are repeated? Or it's not the position that's significant in the extensions, it's the position in the frame that's significant, that previous frames in the Opus payload don't apply, are not having this repeat extension applied to them?
So the second thing you said is correct. The first thing you said was almost correct, but it's the other way around. So the position in the frame is significant, and it basically says you're repeating all of the extensions that you've seen so far in the current frame. Right. So if you then continue coding extensions in the current frame after that, they don't get repeated. So basically, the position in the frame marks how many extensions in that frame you want to be repeated in future frames.
Okay.
All right, so kind of to summarize, like the reasons that we would want to do this is that, you know, we can reduce overhead even if you just have one extension appearing in 2 frames, like you're already saving at least 1 byte. The savings scale with the number of frames and repeated extensions. It applies to any extension, like you don't need to have extra extension IDs to register or SDP signaling. Which I think some other people have proposed some alternative ways to solve this problem. It integrates well with non-repeated extensions like DREAD. So for example, if we went back to that 3 frames in 1 packet with 1 byte repeated extensions, if then you wanted to add a DREAD frame to that in the first frame, it would wind up coming after all of the repeated extensions. And so you could code it without signaling a length because it's now the last extension in the packet, even though it was on the first frame. And finally, the reason to do it now is because if we did it later, it would be a breaking change to extension parsing. So we kind of need to decide if we want to do this before we finish the draft. So the reasons not to do this is, you know, it is additional implementation complexity. I did wind up putting together a patch for it before the meeting here. I think it's like, it adds like 100 lines of code for the decoder and maybe something similar to that for the encoder. So not the most complex thing in the libopus code base. Question is it worth that for, you know, is this a niche enough of a use case that it's not worth it? And then, you know, finally you get the sort of weird thing that the extensions for a frame are no longer guaranteed to be physically contiguous. So like if you just enumerate them in the order that they're in the packet, they won't come out in frame order, which is maybe a little bit weird. I don't think it actually breaks anything. So I don't know, how do people feel?
So has anyone actually looked at this proposal? before Tim just presented it.
Jonathan Lennox, I think this is an audio codec. Complicated algorithms to make things smaller is the name of the game. So I'm okay with implementation complexity. I would suggest you make sure you have a, the document give a full set of examples that can basically turn into a unit test to make sure your parser is correct.
Yeah, I already have something like, I think I have more lines of code for the test right now than the actual feature.
Jean-Marc?
Just to say that to me, the actual format makes sense. I think among the reasons not to do it, like having things contiguous is not an issue for me. I think the only real thing we want to evaluate is the implementation complexity. I've glanced at the source code, but haven't actually read the details yet to see how likely it would be, for example, that another implementation would make errors and all kinds of things. I think so. I want to take some time to evaluate that, but to me, I think that's really the only thing that is worth checking. Otherwise, I have no issue with that extension. It just seems to make sense.
Yeah, there are a few tricky corner cases, so like you are going to want to have good tests for this.
Can you comment a little bit on the things that are tricky and what happens if you mess them up?
Yeah, so just stuff like, so one of the implementation details was, in order to avoid allocating an array to save all the extensions that you have to repeat, like when it's parsing them, it iterates over the ones that are in the packet that it's already decoded, right? So if you have that iterator go up to the repeat this extension ID, if there's padding right before that, you don't want to repeat the padding, right?
You mean you don't want to repeat any padding extension in the frame, even if there is some of that?
Correct. So now, if you then try to use your logic to say, am I on the last extension that I'm repeating to know if I know whether or not to code, use an L = 0 flag for a long extension, you have to make sure you're not looking at the padding as the last extension. So that was one bug I had in the initial implementation. So there's little tricky things like that, but.
Is there any, like, for example, we don't say, right now you've not mentioned what happens if there's more than one RTE in the same frame? Like, should we disallow that to reduce the possibility of problems, or like are these ways of
I mean, like you can say an encoder must not do it, but like this decoder still has to handle if it gets a packet that has that those bytes in it. So currently I just say you only repeat extensions after the most recent RT extension that you saw. So basically every time you see when it updates the pointer to start repeating from. And so it'd be kind of silly to do it multiple times in the same frame, but it doesn't hurt anything.
And I assume if you have more than one extension of the same type in the same frame, they both get repeated.
Yeah, you repeat it multiple times.
Yeah, I think one thing that would be nice, like at this point, it's given how things are, like it's possible we would end up like not using RTE in any of the extensions we have right now. So I don't know if there's like a way of making sure that anything that gets deployed that is supposed to support it, it actually works if it's not used for, like, let's say the first thing that uses RTE is like 5 years from now, and like we wouldn't want everything to be broken with respect to that.
Yeah, I mean, that is a real concern, but other than writing good tests, I don't have a great solution for it.
So that's just echoing from the chat. Mark Harris had a similar concern about whether or not this is already solving something that people are running into. So Tim, what was your motivating use case for this? Did you already see that this was useful for the current extensions, or you're thinking just for future proofing that the overhead when you have many extensions is too high?
So the original motivation was, one of these enhancement extensions that adds side information, right? Because like you're really competing with just spending more bits on the original Opus encoding in terms of what improves the audio the best, right? So you want to keep that overhead as minimal as possible. I think the issue is that, at least from our latest experiments, the enhancement information is already not paying for itself, because the no side information enhancements are actually performing a bit better than expected. Feel free to tell me if I'm summarizing that correctly, Jean-Marc.
I think Yen can confirm also, but that's about what we got so far.
Yeah, so that's why Jean-Marc says, this might not wind up being in the initial deployment. I think those aren't the only reasons you might want to do this. Like, I also think of stuff like dynamic range control metadata. There are certainly going to be other extensions that people will want to encode on every frame. And as Jonathan Lexus says, we are in the business of making things smaller.
Okay, so I'm sensing a little bit of concern over the complexity. Maybe would it help people if Tim, if you'd be willing to actually write up the spec text for this, so that people can actually try to gauge what the real complexity is from the spec perspective. I know Jean-Marc is trying to, maybe look at the code too to see, in pseudocode, what does this look like? But I think maybe people will have a more informed opinion about, is this really complex or is this really rather trivial, if they saw the actual spec text instead of just a slide about it. See if that really muddies up the spec or if it's pretty straightforward.
Yeah, I can do that.
Okay, so rather than just throwing it into the spec, just please post some suggested spec update text to the list.
Yep.
And then we can make a call about whether or not we want to go in this direction.
Seems reasonable to me. So to sort of tie this back into the extension ID numbering proposal from last time, which I didn't get any feedback in, this sort of shows how this would fit into that proposal. So even though the original proposal, I said we were splitting the extension ID space into short and long extensions, we actually kind of have 3 spaces. One of these sort of structural extensions, the 0, 1, 2, which includes the padding and the frame separators, and now this extension. And then you have the range for short extensions and the range for long extensions. So I don't know if people have thought any more about that or had opinions. I think, Mo, you had some alternative ideas that you started talking about the mic last time, but I never saw anything on the list. So.
Yeah, as an individual, I was thinking of a different mapping, and I thought I had actually sent that mapping to the list.
Oh, maybe I missed it.
Yeah, but I think your proposed mapping, works in equivalent ways, so I'm not opposed to it. I would just make sure that people understand what the current limitations are, how big the extension space is for the short and the long, and whether or not people think that's adequate. And I thought there were also some other, even though that space looks rather big, the 8 through 64, I thought there was also some other conditions on that, and that you were still subsetting even that space. Am I misremembering that? I thought there was still some other options within each of those ranges that was also still subspacing those.
You might be thinking of the length, right? So the idea is for the 8 to 63 range, the length is given by the last 2 bits of the extension ID.
Okay, yeah. So it really is subspaced by a factor of 4 for the
Right,
first
exactly.
one, and subspaced by a factor of 2 for the second one.
Yeah, I mean, I sort of expect that for short extensions, most use cases of that are going to be with a fixed length. So like you really can have that many extensions, but like if everybody wants an extension with 2 bytes in it, you're correct that there are 1/4 of many of those is available.
Jean-Marc, go ahead.
I'm noticing this 6 and 7 being reserved with length reserved. Does that mean we're not defining the length for these? And what would happen if we decide to map something there?
Yeah, so I think this goes back to that original question I had asked in the first meeting about like, do we need unsafe extensions? And so the idea here would be that if you see something with one of these extension IDs, just throw the whole packet away, throw the whole extensions away, because you don't know how to parse them, right? Because like if we had wanted to add this extension, like after standardization, like this is a use case where we would have needed that.
Okay, so it's basically 2 reserved code points for unsafe, just in case.
Just in case, yeah. I mean, like you could do something else with it, like define a specific length or something like that, but that was just my proposal.
No, I mean, because I'm not against it. I just wanted to make sure that we understand what it is. And yeah, it might make sense in case there's like another mechanism, indeed, because you just found one.
Okay. Are there any objections to going with this proposal from anyone? Okay, hearing none, Tim, I think you're okay to go ahead and write some text up for this and put it in the next version. And if people have better ideas, they'll bring them to the table.
All right. So any other questions?
Oh, thank you. And just to remind people from last time that the reason why we kept this draft open was because we wanted to get some more information from extension authors about how they plan to design their extensions and what they need from the extension mechanism. So it's largely been dormant for a while, but we wanted to make sure that we actually had extensions looking at it and exercising it before we froze it. I think we're getting closer now to freezing it.
And if you keep it open, I'll keep coming up with more problems to solve.
Okay, close it now. Close it now.
All right, thank you.
Hi. So apologies for the title. This should read Draft IETF MLCODEC Opus Dread 01 now. Do I have control over this? Yes. So quickly, changes to the Dread draft since the last IETF. The draft now clearly explicitly says that the amount of redundancy is unbounded, despite the fact that there's limits to how much is useful. There is a should on having one redundancy per packet, and it should be the first frame. You now must not have more than one redundancy extension for the same frame. The encoder should not encode leading and trailing silence. Any SFU should forward the dread from the last active source, and any mixer should forward or re-encode dread. So these were all discussed in the previous meeting, and the update was made to the dread draft. Whoops. Sorry. So now we get to the fun part of how do we actually write the dread specification and what to specify. So this reflects what's in the document. Not all of that has been discussed in the group, so consider it as a straw man. The idea was to have a normative feature decoder, but the encoder being provided only as a reference. So what that means is we would be defining the computation that the dread feature decoder needs to do, a bit like we described, how the Opus decoder is supposed to proceed. It would be done not as source code, but as text, as we discussed previously. But then we would also have the compliance itself based on test vectors for the decoder, a bit like, again, like we've been doing with Opus. Now, in terms of how this is specified, the idea is for the parameters of the entropy coding distributions, the probability of symbol 0, the decay rate, and so on. Those would be in the draft. They are right now in the latest draft, and that takes up about 8 pages as like 8 big tables. After that, the decoder architecture itself would be defined with a mix of text, math, and pseudocode. It's basically, what layers go where with what kind of activation and so on. And after that, we're left with all of the decoder weights. Those do not fit they do not fit a draft document. The original Opus was not great with the base 64. This would be way worse. So the proposal is to define those in a binary file. And my proposal is for that binary file to be the same format as we have in the current sort of reference implementation of these things. Mostly, the format is not so bad, and it would basically reduce the probability of making errors, as opposed to having like 2 different formats. 2 questions would be, one, whether we use fixed point or floating point to specify these weights. Right now in the draft, I'm linking to a binary file that is based on 8-bit weights, and it's a bit under 1 megabyte. So going with floating point would be a bit under, 4 megabytes. And then the obvious question of where do we publish that file that we need to solve. I don't know if people wanted to comment now or after I'm done with the presentation. I have like 3 more slides.
I think we should probably come back to this point because I'm pretty sure that there'll be some issues raised around how do we do this. People probably aren't thinking about it yet, but once they realize the implications, they'll want to discuss it. So let's go on with the rest of your material, and then we'll come back to this one.
Okay. So this is the
Is the rest of your material just about how to specify this?
yes, all of it is about how we're going to specify this. So this is the proposed binary weights format. It's based on 64-byte aligned chunks with a header ID that says this is weights, this is a constant one, a version number 0 all the time, a type that says whether it's floating point or integer, the size, like the number of weights in the array, the block size rounded up to 64, a name for the weights, which is basically a string up to 44 bytes, and then blocks of data aligned to 64 bytes.
So before you go on, Jean-Marc, Tim, did you have a question on the previous slide or this one? No. Okay.
It was on the previous slide. I just wanted to say that, I'm sure John Mark will not be surprised, but I am a fan of fixed point over floating point.
Noted. One thing to keep in mind is that these are trained as floating point, and things being neural networks, they tolerate errors, and like the fixed point is just like dumb rounding of the floating point. I guess it also depends on whether we want to perfectly match one or the other, or just have like the current what we have in Opus, which is just like a margin of error that makes sure that all kinds of different implementations will pass. Okay. Another aspect in the DREAD decoder is the vocoder. So the first part I discussed is the part that takes the bits and generates acoustic features, which means essentially Capstrum and pitch. And then we have a vocoder that takes the Capstrum and pitch and synthesizes actual audio from there. And the proposal here is to not have a normative vocoder. And the reasons for that is, first thing, the vocoder right now is the part that dominates the complexity of the whole process. It's possible to switch vocoder, and we've actually done it a few months ago when we switched from LPCnet to Fargan without having to change anything else, and things just work. So I think we want to leave the flexibility there. And vocoders are still improving quite a bit, both in quality and reducing in complexity. So I really don't think we should really freeze a vocoder there. But now, how do we somehow specify, or what do we say about the vocoder? There's a few options. You can probably think of more mixes of those. The three main ones would be either define some minimal objective metrics on the vocoder synthesis. So saying based on these features, the vocoder needs to achieve an objective quality of this based on some kind of objective metric we would need to list or define. Another one is to say that performing feature analysis on the vocoder output should match the input. So you have a bunch of acoustic features, you synthesize with the vocoder, and then you try and go back to these features, and it should kind of match with some kind of leeway or something. This is something I've only recently tested with Fargan, and there seems to be some kind of alignment, but it's definitely not that close, despite the fact that it sounds fine. And the other option is sort of completely leave it unspecified and just define how the features work, and then say, use whatever vocoder matches these features. And I know this is wishy-washy. I haven't figured out exactly how this would be said exactly. So these are kind of the options there. And now some more open questions to discuss. I mean, the other stuff is also things we can discuss. First, how do we handle the block sparse weight matrices? Right now, the decoder network is block sparse, so it has all the matrices are based on blocks of 8x4, and each 8x4 tile can be all zeros or something non-zero. So some of the options there, we can just specify everything using a dense format, including, so, you know, all the zeros would be in there. That makes for slightly bigger, a slightly bigger file, about roughly twice the size. Like the decoder right now is on average about 50% sparse. So we can specify them using a sparse format. There's already a sparse format supported with the in the format that I described earlier. Or we could decide to just not use sparse matrices in general and train something dense. It would increase the complexity for anyone who's able to support a sparse format. There may be like some accelerators or whatever that don't support that format, where it would decrease the complexity. That's kind of a trade-off. I still think that sparse is useful here because sort of the lowest common denominators is going to be things like ARM CPUs and that sort of thing, where we're able to take advantage of this 8x4 block sparse format. And those are the ones that, you know, will be more on the edge of the complexity, as opposed to anything like super fast where you don't care. And it's about 50%. So if you can't take advantage of it, you don't take a huge hit. Sorry, Tim, go ahead.
I was just going to agree with you that you know, if you already have an accelerator, like, the complexity is probably not your top issue.
Yeah, I think we probably wouldn't want to take like a 10x hit, which is why so far I've gone kind of conservative on the sparseness. But, you know, I'm happy to take comments there. And yeah, the last thing is, do we say anything normative about how the features are meant to be computed? 18 of these 20 features we're using right now, they're just capstrum, so it's mathematically very easy to describe what the encoder should do with them and what the decoder therefore should be attempting to match. On the other hand, the last two, especially one of the last two, is pitch based on a neural pitch extraction. So that one would be a bit trickier if we attempted to define it exactly. So that's it for what I had to present. So I guess Mo first.
Yeah, one quick question back on the sparse weights. Is this a result of some aggressive quantization, or what is the reason for the sparsity that you're getting today?
So this is trained and with a sort of enforced sparsity, and the idea is that not all the connections in the neural network are equally important. So if you force some of them to be zeros, you can get benefits compared to, for the same number of non-zero weights, you can get better performance with a sparse network. So with an n by n matrix, if you make things sparse, you degrade quality a little bit, but you don't degrade as much as shrinking the n to have the same number of non-zero weights.
Okay.
But these are really forced. They don't just happen out of thin air in training.
Yes, hi. One comment, Jan Büter, one comment about the feature computation being normative or not. I think if they are not normative, then there should be some quality test regarding however you compute the features. This may already be necessary because we don't specify the encoder. So if you just give a reference encoder and anyone can have a different encoder, how is it ensured that quality of the decoded signal is good enough? And I mean, I'm generally skeptical about whether you can easily change the features, especially pitch, with freezing, so to say, the decoder. So it's the question whether it's worth the effort to put such a test in place. At least I think one would need such a test.
Yeah, I mean, I think the question of features is tightly tied with what we say for the vocoder. For example, if we said, you know, this is the vocoder you're going to use and freeze it, then the features would automatically be frozen through that vocoder. Like the entire decoder would be frozen. Considering we don't do that, then we need to figure out something there.
Yes, but I mean, so to say, you could have different features for a new vocoder that works well, but then, I mean, you would distribute this to decoders that might have a different vocoder. So in a certain way, you have to make sure that once you start changing these features, that it works with all possible vocoders being deployed. So I think the same implications are already true for not having a mandatory encoder. I mean, maybe the risk is not so big there because it's trained to match a certain set of features. But once you also start allowing having different features, then I wouldn't dare predict what happens to an arbitrary vocoder.
Yeah, I mean, the combination of the feature definition and the vocoder together needs to be sufficient for interoperability. And exactly how we shift that is the sort of open question I was trying to discuss here.
So Jean-Marc, you have several questions on here, and I assume you're looking for input from the working group about them. But do you have an opinion or a recommendation on any of these issues?
You mean the ones that are on that slide?
Both this and the question of whether or not the vocoder is normative or not.
Yeah. So on these here about sparsity, I think we should keep the sparse. We should keep sparse decoders. With how we specify them exactly, you know, weights or int with or without sparsity, I don't have a very strong opinion in there. I would tend to lean towards matching what the implementation has. So maybe something close to what is right now in that file, either as float or int, or actually I can do both as well. Like that is also easy to have. I would tend to go towards something like that, mostly again because it means it's less likely we'll have errors because the implementation actually uses that format. So, you know, if the implementation works, then the file is probably good. But in terms of float versus in versus both, I don't have a strong opinion there.
Okay, I think if you have opinions and a recommendation, I think it'd be good to state the recommendation on the list or in the draft, and then have people verify or object to that. because I'm sensing there's not enough experts to actually, make a well-informed decision about this or to propose their own variants. So I think it'd be better if you recommend something, then people can analyze that recommendation and dig out whether or not it's reasonable or there's a problem with it.
Okay, in that case, I think I might as well, if it's fine, like I might as well like try and write the draft based on my recommendation, and then people can bash the draft and change whatever is there. Is that fine?
Yeah, wherever you see some degrees of freedom or where you had personal deliberation about a design decision, you can note that, and then people can look at that and see if they agreed with your decision there. So by far, I think the biggest open issue though is whether or not the vocoder is normatively specified, and I think we need to close on that first. And where are you leaning with that right now?
Yeah, so on the vocoder, definitely, I'm definitely leaning towards not specifying the actual algorithm in terms of the requirements from the vocoder. I'm still trying to experiment a bit. I'm kind of leaning right now in the direction of, having some kind of test sequences where we have existing features and we say the vocoder needs to take these and output something that is within a certain quality and within like certain boundaries. So that would indirectly define the features themselves. Like we wouldn't necessarily say, this is how you compute the features, but if you want the vocoder to behave correctly, you pretty much have to compute the features that way.
Okay, yeah, so like test conditions or evaluation criteria.
Yeah.
Yeah, that's very common in a lot of other work. Okay, that's a good start. Is this all of your questions?
So that is basically the main things I wanted to discuss at this point. Like I think maybe when we go further in there, it may raise more questions.
Okay.
Yeah, Jonathan Lennox, I was going back to the specifying the weights. That kind of feels like what you actually want to do is specify a MIME media type for this file, because it feels very similar to like defining it. And then you can have like a, application / Opus Dread weights MIME type or something like that. Because it just, maybe it's only ever going to be one of them, but it still feels like a media type.
These are, to be clear, these are never meant to be distributed or go on the wire or anything. This is similar to source code. So I don't feel like there's really a need for a media type or any of that. Like, this is definitely not a good format in general. It's just about distributing something once.
So a question about, I'm sorry, go ahead, Greg.
So Jean-Marc, you would expect even that implementations would not necessarily even use those weights directly, but they might convert them into some native matrix format with a different precision or whatever is efficient on that implementation. Is that correct?
Well, so the format itself is designed to be efficient on the existing implementations we're dealing with. But if someone were to implement that like on some kind of accelerator, they would probably like do things completely differently, change the order or whatnot.
Yeah, so using the format you're currently using just guarantees that the file you create definitely works for at least one implementation, which is good. But yeah, someone else might use something different derived from that data.
Yes, absolutely. Or go with floating point or fixed point or both or 16-bit or anything. Yes.
Jonathan, did you mean to be in the queue?
No.
Okay, so trying to back up to sort of first principles here. Before publishing the weights and making them some frozen normative things, are you going to, should we specify the model and training set that those weights came from?
That's also another good question that I forgot to raise in there. So I can say right now that all of the data is publicly available. Now, what do we want to do exactly? And the scripts are also publicly available. The exact options that were used, most were default. I don't think the exact details are publicly available. I don't know what would be the best practices that you guys would like. Ideally, it should be repeatable, but there's a lot of random stuff in the training. So I don't know exactly how you guys would like to do it. Probably there's a way to verify. In the best case, there's at least a way to verify that based on the data and the models I have, if you try and train that further, it will stay where it is, which means the gradient is minimized. So there's good indication that this is how I trained them. But it would be hard for someone else to get to the exact point, as opposed to just verify it's in the local minima for that training condition.
Yeah, so if you can document in the draft how someone could reproduce these weights, I think that gives a lot more confidence in the community that this is this is something that they can reproduce, change if they want, iterate on. I'm very hesitant to publish something as normative that no one has any idea how it was arrived at. It almost smells like a malicious vector.
Fair enough.
Shove this binary in your systems and you're good. And you'll have good speech.
Speaking as an individual contributor, I wanted to concur with what Mo was saying there. I think in like artificial intelligence right now, there's a big kind of open debate about what counts as open source. And this is made really complicated by the fact that many of these ML things are using terabytes of training data and hundreds of millions of dollars worth of compute time to train them. But that isn't the case for this work. That it is reasonable to be able to distribute the training data. And as I understand it, the amount of training time is really not that considerable that has gone into it. So I think it would be highly attractive if, to the greatest extent that the training process is made repeatable for this. And if there's technical reasons like, you can't predict the rounding behavior of the GPU used to train it, and so you won't be bit exact, I don't think that's the end of the world, but the closer that we could get to reproducible training on this, I think would be highly desirable.
Well, the thing is the initialization itself is random. So, and you change the exact version of the toolkits, it's going to differ. So I think
yeah, but that would be easy to fix, right? You could just specify the initial random state as like the output of a particular random number generator.
Yeah, but what I'm saying is if you try to generate the same thing like 2 years from now, you won't be able to because of versions, because of everything. So my thought there's maybe 2 ways we could. Okay, there's 3 ways I can think of off the top of my head where we could go. One would be have some kind, I don't know if there's a way to have like an IETF trusted system. It's set up with a card, like a bunch of people hit the command line, see it train, and everyone agrees that everything is good. That would be one. Another one is, I can have the recipe out there, train things, and then, based on the data, as I said, like, you can't prove that this is how I got to that model, but you can continue training and see that the gradient is 0 on that data. In other words, things don't go anywhere. And, this is a local minima for that data. you don't have absolute proof that I did not do something strange, but made sure to be in the local minima. Honestly, I don't know how to do that, but I can't prove it's impossible. That's another approach. And the last one, most complicated, maybe feasible, is we have like a few different groups that try to get exactly the same versions, the same initial conditions, and try to train exactly the same model. I don't know if we would succeed.
I mean, I don't understand why you couldn't, set up a virtual machine image or a Docker image and then adjust the computation graph so that the initial random values are just, their output of the SHA-256 of MLCODEC or something, right? Like,
I'm just saying there's a lot of random stuff, and I don't.
May I comment? May I comment on that?
Sure, go ahead.
So I just wanted to say there are long blocks about making network training repeatable, and it's really notoriously difficult. So you have to track down all the random states, and then you will notice that some of these libraries, they spawn sub-processes, and then they don't get the seed, and so on and so on. So I think the general verdict is that it's not feasible. And I mean, even who knows, you can have a different platform. I think this CUDA code, it's compiled as you push it to the GPU, the version changes, you have different round of errors that can bring it into a different direction. So this degree of accuracy, that's lost, I would say. So basically, you need a good quality metric to see you trained 5 different models and you basically get the same result. That's achievable, but I'm pessimistic about this. You have a Docker image, and no matter where you run it, you will get within an L2 distance of epsilon the same weights out.
Yeah.
Okay.
But yeah, I think Jan also makes a good point. Like I said, you can verify the gradient is 0, but you can also verify that the training loss is at the same level that you would get with an independent model. So it gets pretty tough to fudge at this point. And I don't know if I may ask also, who would be interested in helping or participating in that effort to make like a model that's reasonably verifiable? Thanks, Greg.
Yeah, we have one hand from Greg. I think I would also be willing. If anybody we have a lot of remote participants. If you could just indicate in the chat whether or not you'd be willing to tackle this repeatable weights.
If I may also clarify a few things in terms of what it involves. All of this, the current models have been trained with one NVIDIA 4090 GPU, a single one, with a machine with like 192 gigabytes of RAM, but it can probably work with much less than that. And training data is like 100 gigabytes range, maybe a bit more, a bit less, but that kind of.
So I think to Greg's point, the short of it is this is something you can do with a beefy workstation. You don't need a GPU cloud, or you don't need an entire company to be able to do this type of training. We're not talking about LLM level training. This is something you could probably do on a high-end gaming rig.
Yes, this is literally done on the machine I have in my office. Or alternatively, like, do we have some kind of trusted machine where we can perform this thing and or neutral or whatever you define that? Oh, the one vaguely annoying thing in terms of the training is not everything is perfectly automated. Some of the steps involve like multiple iterative manual command lines where you check that things are converged and then you stop and then you restart another one and so on. It's not great, but there was no trivial way to automate that. But it's a few command lines.
So this is currently not in the current draft, right? The model
Training procedure is
architecture-
not addressed at all.
Okay. Can we get that documented somewhere, if not directly in the spec, somewhere that we can reference so that people that are interested in this reproduction can try it?
Yes. Is it fine? Like right now, all of the code for that is in a Git repo. I can provide the hash and the link, and then maybe like the draft or some document in Git can specify the exact training procedure or something like that.
I think at this juncture, we're not even concerned about the specification element of it, but just the participation, right? That
Yeah.
contributors can go try it out and go like, I can't reproduce this or whatever. And then from there, we could talk about what shows up in the spec, once we've, actually got something that could be specified.
Yeah, if everyone tries and we all come to the same conclusion as Jan, that this is just intractable to get something with reasonably small deltas, then that's good input, that's good information. And then we can decide what to do with the spec text.
Well, I think the spec text is kind of independent of that. Like it's more about how we, or the spec set, one part of the spec is to say that the weights are not dodgy, and the second part is how do we specify these weights? And I think how we specify these weights is an independent question from proving they're not dodgy. Does that make sense?
Yeah, and it's not just dodginess. It's opaqueness. We don't want to be delivering standards that no one can understand and no one has any idea. They're just opaque. And how did you design this? How did you arrive at this? We don't want a standard like that. So if the most optimistic scenario, if Jan is wrong and we can get people to actually, arrive at similar, weights with a defined process, mostly automated, that would be the ideal case. And then we could specify that. And then the weights are just an artifact, and we don't have to actually normatively reference the weights because they're just an artifact of the process.
Well, two things here. One is that even if we succeed, there is absolutely no guarantee that people will be able to succeed a few years from now. The second one is there's still the question of, how do you balance, like you need to use these weights as opposed to you need this behavior, like test vectors and that sort of thing. And then the weights, can be rounded or ultimately, I'm not sure I would go there, but like, would we even want to say this is the behavior? And if you manage to get that behavior from different weights, it would be good. I'm not convinced on that one, but.
I mean, you essentially
there's
argue
like
that if you accept that people may use different precision versions of the weights, right?
Well, yes and no. Like if you look at how we specified Opus, like we say the decoder needs to do this, and this, but you have the fixed point decoder and the floating point decoder and they all pass. So there's a whole continuum between, I don't think we want bit exactness, for example. But going as far as saying you can retrain at totally different weights, that would be another thing. Like we would need to have to be really confident in our test vectors, which especially for ML, I'm not sure I'm that confident.
Okay, so I think we have two decision points here. First is whether or not people are comfortable with just specifying the weights as is, as a binary blob and opaque and no way to reproduce. That's the first decision point. Are people okay with that? And if not, would people like to see the process for being able to generate those and the model architecture and training data to arrive at those. And then secondarily, how does this actually get specified, whether or not we can do reproducible builds? Do we actually specify the normative weights, or do we specify the procedure for generating them as normative? And then finally, if they are normative weights and it's a binary blob that we're standardizing, how does IETF actually procedurally have something like that? How do we, in a RFC, normatively say this binary is the spec? And you're saying it's far too much to embed in an RFC in any way, correct?
Yes.
Yeah, okay, so we've lost Murray. We'll have to take it up with the AD when we get there, but let's first.
And to be clear, if we standardize the procedure, it would be even worse, because instead of being 1 or 4 megabytes, it would be gigabytes of data. So.
Right.
Sorry, I didn't mean to cut you off.
Okay. So Jean-Marc, can you provide all the information that we can start those experiments? Is either on the list or in another draft, or a pointer to a GitHub repo or something that has the information for people that are interested to get started?
For the training procedure, yes. Most of it is already in Git. It's only the exact command lines that are not, and I'll try and provide that maybe on the mailing list for now.
Okay. All right, and the chairs will talk with AD about how, in the eventuality of having to specify a bunch of normative weights somewhere, how do we reference that? Jonathan?
Yeah, Jonathan Lennox. And I guess the other question people want to evaluate is the training data set chosen well? I mean, is there like some part of some type of human speech that has been left out or something that this would not handle well? Yeah.
So the training set is a whole bunch of CC licensed data sets that can be found on openslr.org. They represent many different languages. I had that in the paper, but it's the 30 or 50 languages or something like that, most of which are not English. So the fact that we've been testing mostly with English and that it works fine gives us reasonable confidence. They're basically most of what we could find in terms of free training data.
And sorry, Jan, you were in queue earlier. Did you mean to be there and drop out, or did we forget you and slip you?
Oh, just a small comment. I wanted to throw out another idea. So, in case you want the whole training process to be transparent, still, I would be very happy about being wrong about the reproducibility. But in case I'm not, what you can do is you can actually make you can basically save all the data and update steps that you do. And this way, you can at least validate a training procedure. It's a ton of data, but I think it would be still practical. So you would basically, you would save every batch that you put into your model. You would save the set of model weights, and you would save the update step. And that means that everybody could trace back where did the data come from, what was the gradient that was computed. You can validate this within the precision of floating point precision or whatever. So
I think we're talking about hundreds of terabytes here.
I'm not sure whether it's hundreds of terabytes, but it's 120 epochs times the data set size times
like
the model size.
10,000.
Maybe you don't have to. Yes, but I'm still saying, so it's in theory it's possible. It's a ton of data, but yeah, I mean, it would be possible. Just wanted to mention it.
Yeah, so we'll increase the IETF's bill exponentially next year when we publish this. So Cullen also offered to help navigate the IETF process for standardizing and referencing something and housing something that's highly available for everyone. And everyone, please keep in mind, although we're just specifying, this opus redundancy here, I think this is setting a precedent that we want to be careful about how IETF or any standards body standardizes any ML anything is pretty fertile ground. There's not a lot of precedent for how to do this well and effectively. And if we start off on the foot of, well, we just specify all these binary weights and we put them in a uncontrolled archive that may or may not exist, if someone pays the bills or doesn't, it doesn't seem like the best way forward for other standards. And while this doesn't seem terribly, I don't see a lot of threat vectors on this. Imagine if this work was, to standardize an ML model for good or bad URLs. And when we say, oh, just take this binary and we'll tell you whether or not it's a good or bad URL.
Just curious, is there precedent at IETF for, the main thing that comes to mind is this, magic value for some NIST random number generator that was discovered later to be like, not randomly obtained. But is there a way at the IETF where, some random value was needed for a standard and someone like verified or agreed on a way to determine this value? Maybe we can reuse a similar process.
Colin, go ahead.
Yeah, just to answer that question, I think you see this in the security protocol. Somebody may have mentioned earlier on this call of, we take some string that is hard to manipulate, like the name of the working group or something -1.0, like some string that people sort of agree on, and then we, feed it through a common like SHA-1 or some common hash algorithm, and we assume that that's something that couldn't have been manipulated. But people get so wrapped up around arguing this, and I just come back to I think that if we can get this to be not too dubious of values and we can explain why they are, and some people has a chance of, like, there was a couple people validated sort of our thinking and way we got to them, that we can probably get that through the process. And I 100% agree with Mo that we're in all new territory here. It's going to be really interesting to see what happens, and we're going to be setting, what we do here is going to set the precedent for for other ML things that come in IETF later. So we can expect a lot of pain and suffering on whatever we do.
Great.
And a final comment on the random aspect. I'm not aware of anything that's ever truly random. People do have some TRNG hardware, but it's very rarely used and never ever used for these generic systems and these training systems. These are all pseudo-random generators, and you just have to find where the seed is. And where the randomness really comes in is timing effects. If you have non-deterministic timing effects between parallel processes, that's where the true randomness comes in, and that is very difficult to get to be fully deterministic, like Jan said. So I'm kind of on the same page as him that would be a death knell for us to be fully reproducible. But I'm hopeful that doesn't introduce so much variability that you still can't arrive at very close results. Okay, that's everything for you, Jean-Marc?
Yep.
All right, Jan, you're up.
Okay. I have arrows. Okay, great. Yes, I wanted to give an update on the speech coding enhancement for Opus. So that's a progress report. Nothing happened on the draft side except for an update of Jean-Marc's affiliation to keep it from expiring. Basically this presentation has two parts. The first one is I want to resume talking about requirements for speech coding enhancement methods to be published in the Untitled Chapter. permitted in the Opus decoder. The second part that relates to questions that were raised at the last IETF meeting. So people asked about real world or out of domain signals like far field recordings or music or double talk. And the best answer I could give was haven't tested this yet. So now I can give some feedback on that. And then I will talk a bit about next steps. Also, I want to point out that there is an attachment containing some audio examples that I sent over the reflector earlier today. So let's look at part one, the requirements. So the aim of this draft is to specify requirements for speech coding enhancement methods. So far, not much happened on the draft side because most of the effort went into developing these methods first. But now Opus 1.5 is released, and it includes 2 optional speech enhancement methods. That's lace and no lace. That means we now have integrated methods for testing these requirements. What happened so far is at IETF 118, I presented a study of different objective quality metrics that could be used to assess the performance. And one rather simple method emerged as a promising candidate, a modification of the current Opus compare tool that's used for decoder conformance. It correlates reasonably well with quality, and it's simple to explain, standardize, and to use. There was one better metric that was NOMID, but this is a neural network with 60 million parameters. So I thought it would be best to try and go with the modified Opus compare, at least for starters. So the next question on the agenda is what test data to use. The conventional approach is to use a clean speech data set and to apply controlled degradations. So add noise conditions, simulate different rooms, reverb, etc. But there are certain drawbacks related to this. The first one is that there is really not much free multilingual high quality data available. So the best data sets, they are proprietary. And also it's not clear how well these simulated degradations reflect real use cases. On my search for test data, I came across an interesting alternative that would be the Mozilla Common Voice dataset. That's a pretty large data set of user-generated clips. So the quality, it's typically people sitting in front of their laptop or using a headset or whatever, just recording their own voice and uploading it, and it's all merged into data sets. So that means the quality is on average not great, but it can range from pretty good to noisy to reverberant, far field, near field, everything in there. And I would argue that the recording scenarios are actually very relevant because people would record these clips the same way they would probably use their computer for internet communication. Also, the data covers 100+ languages, and it's gathered from all over the world. And this might address some concerns regarding real-world data. So are we testing on relevant data? So what I did is I ran a test. I downloaded this rather big data set. I did some pre-processing. So testing is done on a per language basis. From every language, I selected 10 samples, 5 female, 5 male, sampled uniformly from different sources to have enough variability. That's done by client ID. And languages that have not enough samples or all the samples from the same origin, that they were excluded. So that left in the end 81 languages or dialects. The items were converted to 16 kilohertz, so it's a wideband test, and normalized to -6 decibel full scale. And the script for item selection, that's on the Opus branch, on the Opus main branch. The test setup is straightforward. So test clip goes into the reference encoder. It's decoded by a reference decoder and an enhanced decoder. and original, reference decoded, and enhanced decoded output are samples are compared to, and a relative delta distortion value is computed. I will tell you now what that is. So for this relative delta distortion, that's based on modified opus compare. Modified opus compare is a degradation measure, so it tells you how far your signal is away from the reference with some perceptual weighting. And so what I took for a relative delta distortion is basically to take the difference of the square root of the degradation of the reference decoded signal minus degradation of the test decoded signal and normalized by the degradation of the reference decoded signal. And the idea here is that if you have small degradations, then you want to put a higher weight on deviations than if you have high distortion to start with. For test criteria to pass the test, I picked two different criteria. One is basically on a per item base. So maybe one thing to point out. So this relative delta distortion, it means if it's large, then test is closer to, or if it's larger 0 and large, then test is closer to the original than reference. And if it's smaller than 0, then it's the other way around. So the distortion is getting bigger. So the first criteria that limits the worst case relative delta distortion. So the minimum distortion is supposed to be larger than a threshold. And the second one limits the average relative delta distortion, also supposed to be larger than a threshold. The test scripts to run this test is also on the Opus repo, so it should be possible to reproduce it. Now, as test conditions, I used as reference encoder and decoder just Opus 1.5.2, and the reference decoder has a decoder complexity of 0. The next test condition lace is the Opus 1.5.2 decoder with DEC complexity set to 6 and no lace with DEC complexity to 7. Similar to the first study at IETF 118, to simulate some bad models, I basically use lace and no lace, but with weight files that are not fully trained. So they're just trained for a few steps. And there are some examples how it sounds. So it's not catastrophic, the degradation. But there is an audible degradation in quality. It's also included in the attachment. Okay, results. I picked some thresholds that basically are designed to let lace and no lace pass and let bad lace and bad no lace fail. And they are theta min equal to minus 0.1. This means that we allow, or we'd allow to the modified opus compare value to increase by about 10%, or better, the square root of that by 10%. And for the average, it's set to minus 0.0.2, so it allows for a distortion increase of 2.5%. And this way, basically all good methods pass and the bad ones fail. For lace, at 6 kilobits per second, not all tests fail, but enough that you would reject that method. And I mean, it looks a bit questionable that you have to allow increase in distortion. So what I did is I also included the worst case items for no lace, which usually has a larger distortion value assigned than lace. And personally, I did not find any perceptual degradations to me. They looked, they sounded slightly better, but they are included also in the attachment for others to review. Okay, so that's it basically for part 1, the test part. Now about part 2. that addresses the question about out of training domain signals. So to refresh your memory, training data is really clean speech. It has been tested on noisy speech already, that worked, but it hasn't been tested on music or double talk or far field recordings. So basically, the most interesting thing for you to do is, I think, listen to the samples in the attachment. But I want to give, so to say, a very short overview how these items were generated, what the subjective impression is, and also report the modified opus compare scores. So as a music example, I took a short violin clip, and it's noteworthy that the fundamental frequency range of the tones are within the range of human speech. And what I observed is first that the item is also classified as speech, which is not surprising. But the output of the legacy opus and encoder decoder, that's not great. And if you wonder what the reason for that is, it's that the pitch detector misdetects a lot of pitch values at the encoder. The good news is that on the listening impression, both lace and no lace improve on that quality, but still, even with no lace, the quality is not great. But a good sign is that it indicates that lace and no lace, they are robust to pitch prediction errors. That's also reflected in the modified opus compare score. So recall that better, lower means better, and at least lace and no lace receive lower scores than opus. For a far field recording, I used an artificial item. So I took a clean speech clip from the EBO-Squam CD, and I processed this with a real room impulse response. Again, the observation is that both lace and no lace improve on opus, and the quality is on average a lot better than for the music sample. And a third example is double talk. So for double talk, I basically did a stereo arrangement of two clips from the EBO-Squam CD, added a little bit of stereo reverb, and did a downmix that basically simulates two people, two talkers in one room. And performance is also quite good. Both opus performance and lace and no lace make it again better. So all in all, that's reassuring, and it's also reflected in the modified opus compare scores. However, you can note that usually modified opus compare thinks that no lace is slightly worse than lace, although it's the other way around, so it's not perfect. So the conclusion from these experiments are that the test on common voice that successfully distinguished good from bad enhancement methods. Though admittedly, the number of test conditions is not very large. If somebody has an idea how to come up with better ways to simulate a bad model, I would be very interested in hearing it. The second thing is that in the current setting, the thresholds must allow a small modified opus compare degradation, but the listening impression is still that the enhanced signals usually still sound better, but feedback on that is very welcome. So worst case examples are included, as I said. Regarding the critical test items, it was quite reassuring to see that Opus 1.5 enhancement methods also improved that. Also, please hear for yourself. And yes, I mean, modified Opus compared in sum is moderately successful in confirming quality improvement of enhancement methods, I'd say. So the questions that arise now is, I mean, it looks like a viable path forward to say, we take this common voice test sets, these 81s, we could add a small clean speech test to that. We could add that this is actually a typo. I didn't want to write far field, but double talk, because far field, that's in common voice. And we could also extract some single instrument music clips to add three test conditions to these 81 from Common Voice. And then we could say we do have a test data set. Yes, but I would be very interested in hearing your opinion. Do you think test coverage would be good enough with this? Is the method acceptable? If that's the case, the next question will be, do we want to have a reference encoder decoder like in the current setup, or which would mean that we basically have to provide storage for 120 megabytes for raw audio? Or do we want to provide really test vectors? Then that would basically increase by the number of test points plus 1 times 120 for raw audio, because we would have to basically store the reference decoded output clips on top of the clean ones. There could also be a hybrid way of encoding bit streams, but allowing a reference decoder. Then we would just have these 120 megabytes plus the storage for bit streams, which is smaller. And then the big question is, where would we host this data?
No worries. We'll have a multi-terabyte array for Jean-Marc's spec. So this will just be a drop in the bucket.
Yeah, training execution trace, 400 terabytes, no problem. This is a rounding error.
So, Jonathan, so is this, I guess my taking a step back, is this actually standardizing anything, or is this just, things I use to make Opus better?
It's standardizing something. It's basically standardizing a set of requirements that once your enhancement method fulfills this, you can put it into the Opus decoder and it's conforming to the specification.
Okay, so it's basically it's what has to be done to an Opus decoder, so you're still conformant for the purpose of the patent licenses or whatever.
Yes.
So okay. Can you further clarify? I thought earlier Tim made a point about side information versus no side information. Clearly, the ones with side information would need some standard, right?
Yes. So, that was already a spoiler from Tim. There was a first attempt. A colleague of mine carried this out to use side information, just to add some information at the encoder and add this to no-lace. And it improved quality a bit, but not enough to pay for itself. So the first attempt failed, but that doesn't mean there will be other attempts that will be successful. And in that case, that would need to be specified, yes. Also, if you wanted to do something, for instance, about this pitch problem that's on this violin sample, that could also be something that might be worthwhile looking into. So to improve the pitch detector at the encoder. Not making any promises, just saying it might be interesting.
Jonathan, are you meant to be in queue or are you?
Oh, no, that was good.
Okay. Go ahead, Jean-Marc.
Yeah, just to give some context on the difficulty of side information, specifically for the case of speech. This is completely different from the other use case we've not worked on so much yet, which is to do it on music. But for speech, what happens is we can't do lower than 6 kilobits per second just because the encoder won't do it. And to some extent, like no-lace has been working so well that at 9 kilobits per second, it's very close to transparent. So the range where this would have an impact would be between like 6 and 8 kilobits per second, and we have like about 1 kilobit per second of signaling at the minimum that we would need to do. So that leaves like a very narrow range. Maybe there's something we can do, but I'm getting slightly less optimistic, and that's kind of where it comes from.
Thought you were sending entire voice signals in 1 and 2 kilobits now.
Yeah,
Why can't you just enhance it?
Well, that's the problem though, because 1 or 2 kilobits is what the enhancement signaling takes up. You just send a whole nother voice signal in that, right? Yeah.
Okay, so just to clarify Jonathan's question then, will there be anything for us to standardize if you become of the opinion that a non-signaling based method works reasonably well? Jan, that was a question for you.
I mean, a conformance requirement is a standard, right? To the best of my knowledge.
Okay, so you would like to specify how to measure whether or not you actually have a good effect.
Yes. I mean, maybe not to measure whether you have a good effect, but just to have a safeguard that you don't put something in that doesn't work, or isn't general enough. I mean, if people are fine with allowing whatever, that's also a way to go.
Jean-Marc?
Yeah, I mean, I think there's just like a few things we want to guard against. Like one, obviously, is people deploying like anything without validating anything. Another one would be like systems that rely on a modified encoder and interpret things differently and that sort of thing. So it's just a matter of setting a boundary of what is okay to do and what is not okay to do.
Tim?
Like, yeah.
Tim, are you trying to talk?
Yeah. Sorry, I was just going to ask if you had thought more about an extension that would turn this off on a frame-by-frame basis.
I thought about it some time ago, but I don't see the use case that much. I have to say. Mainly also because I haven't found a problem with the enhancement methods yet.
Yeah, that does make it harder to figure out if it's useful.
Yes. Yes. So at the moment, I don't see the use case for that.
Yeah, all right.
Or
Jean-Marc?
Yeah, I can see a few issues with turning that on and off. Like one is that unless you specify an extension that says turn it on for now or turn it off for now, which itself is probably not a good idea because you could lose the packet. Otherwise, like you end up spending quite a few bits signaling that it may not be worth it. So I'm not convinced it's a good idea unless there's something really compelling that I missed.
You mentioned the violin sample. Have you done much testing with putting music through it? Because that strikes me as a case where you might have more cause to turn it off.
I haven't done more. I mean, basically the question is if you have general music, then it's less likely that the speech coder would code it. So that was the reason for going with a monophonic signal and to see what happens there. But I'm very happy to put through the whole Squam CD with all the music clips, including ABBA and whatnot, and share the results. So yeah. So
Okay.
I'll put this on my to-do list. Okay.
Jean-Marc?
General comment about music, like we're talking about something also for very low bit rates. That's where it has an impact. So if you're at like 24 kilobits lace and no lace and all these, they should really have like very little impact. And if you're coding music at 6 kilobits per second, like it can do whatever. It's going to be bad no matter what. So I'm not concerned. you get what you deserve.
Okay, so Jan, you're not asking for adoption at this point, and you're just going to continue
Yes.
iterating on these two models?
Yes. Yeah, I think so. I should have some more draft text before considering adoption. That's my feeling.
Okay. What's the name of the test suite that you were going to run through?
The name of the
When we're referring to the music stuff, that was the Squam.
it's a SQUAM CD. It's from the European Broadcasting Union. Is for signal quality assessment material. EBU SQAM. That's about 50 clips or so with music, speech, single instrument recordings.
Okay. So thank you, Jan. We'll look forward to your updates.
Thank you.
So that's the end of our agenda. Does anyone else have anything else they'd like to bring up? All right, hearing none. Happy Friday. Enjoy the rest of the IETF or enjoy your trip home or enjoy Vancouver.
Thanks, everyone.
And thank you for the notes, Jonathan. Is it going to be tight for you?
No, well, I think I can't make the